All right, final target for this key concept. We are talking quadratic equations and the real world. So we've got real world problems that we're applying quadratic equations to. Learning goals for this lesson. So by the time you are done, you should be able to create a quadratic function that models a real world situation when you're given information. Create a quadratic function to model the area of an object. You're going to be doing this a few times. Create a quadratic equation using the vertical motion model. You are also going to be doing this a couple times. And use a quadratic function to find the dimensions of a rectangular object with and without a border, which these two, the area and that, are kind of related. So let's just take a look at our first example because there's nothing really to touch on first. Other than something that I've just kind of like embedded in this problem. So, John's hitting baseballs. He hits the ball from a height of 5 feet. The ball leaves the bat with an initial velocity of 50 feet per second. Write the function using the vertical motion model. You might be asking, what, Mr. Higgins, is the vertical motion model? This is it right here. So this that you see, h equals negative 16t squared plus bt plus s. So, this is negative 16. That is your acceleration or gravity, depending on the problem. So, generally speaking, if there's nothing there, we're going to have it as a negative 16 unless the problem specifies otherwise. V is always going to be your initial velocity, S is your initial height, and then H is your height at any given time. So, if I say like after 3 seconds and I plug in 3 for t and get an answer, that would be the height at 3 seconds. But all we have to do is write a function. So all we're looking for is where gravity or acceleration is not mentioned, and initial velocity is, which notice that's going to go in for v, and then our initial height of 5 feet is mentioned. Okay? So we just plug those in to get h equals negative 16t squared plus 50t plus 5. Next problem. The length of a rectangle is 10 yards more than its width. Let w represent the width. Create an expression that calculates the area. So before you do this, you need to remember the formula for area, which is width times length, base times height, however you want to look at it. In this problem, we're talking about width and length, though we're going to use those. So our width, we're told, is w. Okay. Our length, we don't have an exact variable for. We just know that it's 10 more than its width. So we can write it as length equals our width plus 10, because it's 10 yards more. So we can plug these two expressions. We've got w and w plus 10, because notice it's width times length. So I can have my answer as a for area equals w, which is the width, times the length, which is w plus 10, and make sure to put that in parentheses. You don't need to do anything other than that either. I mean, if you really wanted to, you could expand it and get w squared plus 10w, but we're not going to ask you to do that. Third example, a ball is thrown straight up from 7 meters above the ground with a velocity of 11 meters per second. Gravity pulls it down, changing its speed by about 5 meters per second. Create a quadratic equation to model this situation. Okay, vertical motion model again. So notice this changed to a negative 16. So we kind of gave you that. But the thing to remember is this minus 5. Okay, this is gravity pulling it down, hence the negative, by about 5 meters per second. So that's where that 5 comes in. So that's already been put in for you. But the thing to remember is if we go back to this is acceleration or gravity. So since you see that word gravity mentioned, hopefully you can make that connection, which only leaves the initial velocity and its starting height. Okay, you might not always have a starting height, in which case this would be left off. Like if you have whatever it is starting from the ground, then you won't have a constant in there. But as it is, our initial velocity is 11 meters per second. Starting height, which is c, is 7. So we just plug those in, and we are good to go. Next, all right. Length of a rectangular plot is 10 yards more than its width. If the area of the land is 600 square yards, find the dimensions. W represents the width. Okay, so there's w. That's our width. We want to create an expression in terms of w for length. So the thing to remember here, so if this is our width, this is our length right here. All right, and we've got to go and look. It says our length of a rectangular plot is 10 yards more than its width. So we can write it as w plus 10. For those of you who want a visual, this is what it looks like. Create and solve an equation to determine the width. Well, if we're going to determine the width, then we're basically solving for W. So we're going to set it up W times W plus 10. Now notice I have 600 here, not a variable. That's because this is the formula for area is width times length. But in this case, I'm just switching the side, so it's width times length equals area. Well, I know that the area of the land is 600 square yards, so that's where I got this. My length is W plus 10, and then width is a W. So now I'm just going to go ahead and distribute this. W times W is W squared. W times 10 is 10W and 600. And to make this a proper quadratic, we're going to subtract 600 from both sides to give us W squared plus 10W minus 600. Now we have it set equal to 0. Now we can solve whichever way we want. Okay, you can solve by factoring. You can solve by the quadratic formula. You can solve by using a graphing utility. So we'll just say graphing. Okay, you get the idea. There's lots of different ways that we can solve this. You choose whichever one works for you. You're not told to solve it any particular way, but this we solve, and we get 2 W's, or what, if you're using a calculator, you might have to put it as X's, of negative 20 and 30. Now remember, our width is just W. We can't have a width that's a negative number, so we don't include that. We don't include negative numbers when we're talking about real-world problems. So all we're left with is W equals 30. Now we need to calculate the dimensions. We know that the width is 30, but we don't officially know the length, but it's easy enough to find out, because we do know the length is 10 more than the width, giving us a width of 30 yards and a length of 40 yards. All right, last problem of the last target of this unit. Okay, the combined area of the 3 window panes and frames shown below is 924 inches squared. 924, sorry. The frame is of uniform width, meaning it has the same width. This space around the 3 window panes is the same all the way around. What is the side length? X. So we want to know the side length, just this right here. Okay? Because each of these sides is the same length, because each window frame is a square, so each side length is the same. Solve using any method. All right, so the thing that I want to kind of like set up here for you is to remember, and you might want to do this, that's 6 inches. That's 6 inches. This is 6 inches. Now you might be wondering, why am I doing this and not everywhere? Well, if you notice, I've got a line here and a line here. So what we need to do is set it up so we have area again is width times length. The width is 3x plus 12. I'm telling you that right now. Take a minute, see if you can figure it out before you continue. But again, all of these square panes are uniform, which means this has a length of x, this has a length of x. So how many x's do we have? The 3 of these together are 3x from here to here. Okay, so we have 3x here, and then 6 and 6 is 12. Oh, look at that. So now that you know that, what do you think the length is? Well, hopefully, and if I got it backwards, it really doesn't matter. You can again see 6, 6, but this time we have a distance here of just x, so we have x plus 12. And then we multiply the 2 together, and we set it equal to 924 because we know that the area is 924, because that's including the frames. All right, so we multiply those together. Use FOIL to get 3x squared plus 48x plus 144. Then subtract the 924 from both sides so that you can set this equal to 0, which will give you a negative 780. Okay, and a clue that you're on the right path is this ends up being a negative number, you're good. If it ends up being a positive number, you're probably doing something wrong. And then again, solve by any method you want, factoring, graphing, quadratic formula, etc. And you're going to get x equals negative 26 or 10, but again, we cannot have a negative, all right? So we can only have the positive. So x is 10, and notice that's where we can stop, because this is 10, this is 10, this is 10. So each side length is 10, so we've already answered the question. Side length is 10 inches. That is all I have for you guys on this lovely day. So you have yourselves a good one. If you have any questions, do not hesitate to ask me. And as always, you guys take care and thanks for listening. Bye-bye.